at what is passwordless authentication, what are the different types of methods available, the benefit it offers with real-world example, and its best practices for implementing in your organization and for your personal use. So let's get started. We all know in today's digital age, we rely heavily on online services and applications to conduct our daily business and personal lives. But with this increased reliance comes an increased need for security, and that is where passwordless authentication comes in. Passwordless authentication is a method of user authentication, and as the name also suggests that it does not rely on the use of passwords. Instead, it uses other forms of authentication such as biometrics, security token, or one-time code sent via text message or email to verify a user's identity. The idea behind passwordless authentication is that it offers a more secure and convenient way of authenticating users as compared to traditional password-based authentication, where passwords can be easily guessed, stolen, or forgotten and are often reused across multiple systems and services. Passwordless authentication methods, on the other hand, are less susceptible to these types of attacks and can be more difficult to impersonate. In recent years, we have seen a growing number of organizations and individuals turning to passwordless authentication as a way to improve their security posture. And this is because passwordless authentication provides a more secure and convenient way of accessing sensitive resources without the need to remember and manage multiple passwords. There are several different types of passwordless authentication methods, each with its own unique advantages and disadvantages. Let's take a look at a few of the most popular methods. And the first one is biometric authentication. This method uses a user's unique physical or behavioral characteristics such as fingerprints, facial recognition, or voice recognition to verify their identity. Biometric authentication is becoming increasingly more popular as it is easy to use and it is difficult to impersonate. For example, Apple's Touch ID and Face ID are the most popular biometric authentication methods on smartphones. Second one is security tokens. This method uses a physical device such as a USB key or smart card to generate a one-time code that is used to authenticate the user. Security tokens are highly secure as they are difficult to duplicate or steal. They also provide an additional layer of security as the token must be in the possession of the user to access the service. Some popular security tokens are Google's Titan Security or Ubiquitous YubiKey, and third one is one-time password. That's also called OTP. This method sends a code via text message or email to the user's mobile phone or email address. The user then enters the code to complete the authentication process. One-time codes are convenient as they can be sent to any device and they are relatively easy to implement. Google Authenticator and Microsoft Authenticator are a few examples of one-time code-based authentication. Now comes to benefits. Passwordless authentication offers several benefits over traditional authentication methods that rely on passwords. First is increased security. By eliminating the need for passwords, passwordless authentication reduces the risk of password-related security breaches such as password reuse, weak passwords, and phishing attacks. This makes it more difficult for attackers to gain unauthorized access to sensitive systems and data. Next is improved user experience. Passwordless authentication methods such as biometrics and one-time codes are faster and more convenient for users than entering complex passwords. This can help to reduce frustration and improve the overall user experience. Next is reduced administrative overhead. Passwordless authentication eliminates the need for users to remember complex passwords and for administrators to reset forgotten passwords. This reduces the administrative overhead associated with password management. Improved accessibility. For users who may have difficulty remembering passwords or typing them accurately, passwordless authentication methods such as biometrics can provide a more accessible way of authenticating. Increased adoption. By making authentication faster and more convenient, passwordless authentication can increase adoption of secure authentication practices. Let's take a look at some real-world examples of organizations that have adopted passwordless authentication and the benefits they have seen. Here are a few real-world examples of organizations in India that have successfully implemented passwordless authentication. HDFC Bank. HDFC Bank, one of the largest private sector banks in India, has implemented passwordless authentication for its mobile banking application. Customers can log in using biometrics or a one-time code sent via SMS. This has helped to improve the security and user experience of HDFC Bank mobile banking services. Kotak Mahindra Bank, one of the leading private sector banks in India, has implemented passwordless authentication for its mobile banking application. Customers can log in using biometrics or one-time code sent via SMS. This has helped to improve the security and user experience of Kotak Mahindra Bank's mobile banking services. Paytm, India's largest mobile payment and financial services company, has implemented passwordless authentication for its mobile app. Customers can log in using biometrics or a one-time code sent via SMS. This has helped to improve the security and user experience of Paytm's mobile app. PhonePe, a leading mobile payment and financial services company in India, has implemented passwordless authentication for its mobile app. Customer can log in using biometric or one-time code sent via SMS. These are just a few examples of successful implementation of passwordless authentication. The adoption of passwordless authentication is growing rapidly in India, and many more organizations are likely to implement similar solutions in the coming years. Here are some best practices guidelines for implementing passwordless authentication. First, use multiple authentication methods. To provide an added layer of security, it's best to use multiple authentication methods. For example, you could use a combination of biometric authentication and security tokens. This way, even if one method is compromised, the attacker would still need to bypass the other method to gain access. Second, encrypt sensitive data. Sensitive data such as biometric and security tokens should be encrypted both in transit and at rest. This ensures that even if the data is intercepted or stolen, it will be difficult for an attacker to access it. Use a secure storage for tokens. Security tokens should be stored in a secure location, such as hardware security module, which also called HSM, or a secure element in a device. This helps to protect the tokens from physical attacks and unauthorized access. Regularly updating system and software can help to patch any known security vulnerabilities and keep the system up to date with the latest security features. Monitoring and logging user activity can help to detect any suspicious activity or malicious behaviors, and can also be used to investigate any security breaches that may occur. Regularly reviewing and testing the security of a system can help to identifying any potential vulnerabilities and ensures that system is functioning as intended. Implement a user education program. It's important to educate users on how to use passwordless authentication methods properly and to be aware of phishing and social engineering attempts that could trick them into giving away their tokens or biometric data. Here are a few tips of how to secure passwordless authentication methods. Encrypt sensitive data such as biometric templates and security tokens both in transit and at rest. This ensures that even if the data is intercepted or stolen, it will be difficult for an attacker to access it. Security tokens should be stored in a secure location such as a hard security modules, also called HSM, or a security element in a device. This helps to protect the tokens from physical attacks and unauthorized access. Use secure communication protocols such as HTTPS or SSH to protect data in transit. Use a secure key management solution to protect the encryption keys used to encrypt data. This ensures that only authorized parties can access the data. Use multi-factor authentication to provide an added layer of security. For example, a user will be required to provide a fingerprints and a security token to gain access. Keep software and firmware up to date to ensure that the software or the system is protected against latest security threats. Use a secure management solution to monitor and log user activities and detect any suspicious activities or malicious behavior. Regularly reviewing and testing the security of a system can help to identify any potential vulnerabilities and ensure that the system is functioning as intended. As we have seen so far, passwordless authentication is a powerful tool for improving security and convenience. However, it is important to remember that the passwordless authentication is not a one-size-fits-all solution. Different methods may be more appropriate for different use cases, and it's important to carefully consider the specific needs of your organization when implementing passwordless authentication. That being said, I would highly recommend that you consider implementing passwordless authentication in your own organizations or for your personal use. The benefits it can bring in terms of security and convenience are well worth the effort, and it can help to protect your organization and personal information from cyber threats. Once again, with the right planning and implementation, passwordless authentication can be a very powerful tool for improving security and convenience. If you are interested in learning more about passwordless authentication, I encourage you to do more research and reach out to me anytime for any more information. Thanks for watching, and be sure to check out my other videos for more information on cybersecurity and other related topics. If you haven't subscribed my channel yet, please do subscribe my channel, like and share my videos. Hello and welcome to my channel. In this video, we will understand about adaptive multi-factor authentication. I will give you a brief overview of adaptive multi-factor authentication and how it works. What is the difference between multi-factor authentication, the benefit, what it offers. I will also provide you the steps that organizations can take to implement adaptive multi-factor authentication with the real-world examples of the organizations that have successfully implemented adaptive multi-factor authentication. So let's get started. Before we get into the actual topic of adaptive multi-factor authentication, let's quickly understand what multi-factor authentication is and how it works. As you can see over here, multi-factor authentication is a security method that uses two or more factors to confirm a user's identity to access any kind of resources, such as applications, online account, etc. So that it requires minimum 2 factors or more than 2 factors to get access of the resource, rather than just a user ID and password. As you can see in this diagram, where the user is asked to provide the username and password as the first factor, and the OTP, in this case the OTP is asked as a second factor, and the fingerprint biometric as the third factor, right? So user ID, password, then PIN, and then fingerprints. There are several popular multi-factor authentication methods. One of the factor is knowledge factor, means something the user knows, such as the password, right? Second is the possession factor, something the user has, right? And like the smart card or so. And the next is the inherent factor, which says something the user himself is, such as fingerprint or facial recognition or retina scanning, right? What the user is. Next one is time-based OTP, that's also popularly called TOTP. It generates a series of numbers through QR code scanning. One of the example is Google Authenticator. So that QR code it generates, and through the QR code it generates the sequence of the series of the numbers. So this is what actually I have mentioned over here. So one of the best example is Google Authenticator. Next one is push-based 2FA. That push authentication sends notifications. So basically it sends a notification through over the network. So it requires basically your mobile should have the network connectivity to the end server. Next is very much popular is the secret question. So you can set the questions that users can answer to verify their identity. Now that we understand multi-factor authentication, let's move on to the adaptive multi-factor authentication, also known as risk-based authentication system. Adaptive multi-factor authentication is a security system that uses machine learning algorithm to analyze various factors such as users' behavior, their location, device information, and login history to determine the level of risk and adjust the authentication requirements accordingly. As I mentioned, it's a machine learning algorithm it uses to analyze behavior, location, the device what the user using, and the login history to determine the behavior of the user and to risk a score of the user. This means that the system can automatically prompt users to provide additional form of identification if the risk level is way high, or it can allow users to bypass certain authentication methods if the risk level is low. Adaptive authentication takes advantage of real-time analytics to get a complete picture of the circumstances surrounding each login. When a user tries to sign in, an adaptive authentication system looks at things like device verification. So these are the different methods what adaptive multi-factor authentication offers. One is the device verification. Is the user using their personal laptop instead of using a company issued laptop? So this checks if the user is using a trusted device. Okay. So if you are using a personal laptop, it will be prompting you that okay, this device is not trusted if you are inside the office. Second one is location verification. So this is the location verification. Is the user trying to access his system using a public network rather than the company's network? Or is the user in another time zone? So all these checks are being performed in the location-based checks during that location check. So the network what it uses, the device recognition for MFA, adaptive authentication combines these data points with the historical or contextual user data. Next one is IP address verification. The meaning of it is the employee connecting from a known IP. Okay, or is it from another country? So all these IP related checks we perform in IP address based verification. Let's understand how adaptive multi-factor authentication helps to increase the security of an organization system and resources by taking it more difficult for attackers to gain unauthorized access, right? So the whole objective is to prevent the unauthorized access through the adaptive multi-factor authentication, right? It can also provide a more convenient user experience by only requiring additional authentication factor when necessary rather than every time a user logs in. So it is not necessarily to prompt whatever we have configured as a multi-factor authentication. So it is not necessary that the user will be prompted every time all those set of the same MFA. Basis on the risk scoring, the system itself will decide whether it is necessary to prompt additional factor or let the user get into the system. Okay, so this is what actually I am trying to highlight over here. Overall, adaptive multi-factor authentication is an important tool for organizations that want to protect their systems and resources from unauthorized access, as it can provide an additional layer of security beyond a traditional user and password. Now, let's understand the difference between standard multi-factor authentication and the adaptive multi-factor authentication. Multi-factor authentication is the present and adaptive authentication is the future. Having said, while MFA could help in tackling the security issues in the present scenario, enterprises looking at a long-term perspective need to focus on integrating adaptive authentication. For instance, establishing the identity of a user through a step-up OTP might not be the most ideal solution every time, as it is device dependent and anyone may access someone's mobile phone or hack into the email ID to get the authentication data, right? So that step-up OTP might not be the ideal choice every time, right? Adaptive authentication takes user and behavior context a lot more closely compared to standard MFA, which is just another factor in the authentication process. It is based on a matrix of variables that provides a risk profile of a user, and based on this risk profile, the system generates additional authentication processes before the user is allowed for the access. While normal MFA could be part of the adaptive authentication process, it is much more intuitive and real-time, with factors such as knowledge-based questions, geolocations, and identity assurance making the authentication system more robust. Okay, next is dynamic and real-time security. You must have seen MFA, standard MFA follows a set of patterns and has certain processes to be followed. Whereas with regards to adaptive authentication, the end user is an integral part of the security, such as through SMS or email, and knowledge-based authentication helps in creating a dynamic security system, which is difficult to hack. The move is towards behavioral aspect of users rather than device-based simple password and OTP. It offers a new way of identity verification. Adaptive authentication helps in setting up additional identity verification through various channels, including integrating hardware solutions such as biometrics. So this is very important to understand, as passwords are seen as the weakest link in any security system nowadays. Backing it up with additional authentication, especially biometrics, ensure that only the authorized person is able to access the system. Let's find the benefit of adaptive multi-factor authentication. Adaptive multi-factor authentication provides several benefits that can help organizations to increase the security, as you can see here. Increase the security of their systems and resources and improve the user experience. First, it increases the security by requiring multiple forms of authentication and continually assessing the risk level associated with a particular login attempt. Adaptive MFA makes it more difficult for attackers to gain unauthorized access to systems and resources. This helps to prevent data breaches, unauthorized access to sensitive information, and other security incidents that can result from a single point of failure, such as weak password. Preventing unauthorized access to sensitive information, okay, and the data breaches, as I have mentioned over here. Second, it provides convenient user experience. Adaptive multi-factor authentication provides a more convenient user experience by only requiring additional authentication factors when necessary, based on the level of risk associated with the multiple login attempt. This helps to reduce the friction associated with the logging in, while still maintaining a high level of security. So as and when required, if it is necessary, then only it will be prompting for an additional factor, or it will allow a user to get into the system. Next is prevents unauthorized access. Adaptive multi-factor authentication helps to prevent unauthorized access to systems and resources by requiring users to provide multiple forms of authentication and continually assessing the risk level associated with a particular login attempt. In summary, adaptive multi-factor authentication provides increased security, more convenient user experience, and helps to prevent unauthorized access to system and resources by making it more difficult for attackers to gain access. Now, let's take a closer look at adaptive multi-factor authentication implementation steps. Implementing adaptive multi-factor authentication in any organizations involves several steps, including determining the types of authentication factors to use, selecting the right tools and the technologies to support the solution, and establishing the level of risk the organization is willing to tolerate. Some of the steps are: determine the types of authentication factor to use. Here, organizations should decide which authentication factors they want to use in their adaptive MFA solution. These can include something the user knows, like a password or PIN number, something the user has, like a smart card or security token, and something the user is, like fingerprint or a facial recognition. It is important to choose authentication factors that are easy for users to access and use, while also providing a high level of security. Second is select a right tool and technologies. Here, organizations should choose the tools and technologies that will support their adaptive MFA solution, such as identity and access management software and biometric authentication devices. They should also consider how these tools and technologies will integrate with their existing systems and infrastructure. So this is very much important. Next is establishing the level of risk tolerance. Organizations should determine the level of risk they are willing to tolerate in their adaptive multi-factor authentication. This includes considering the potential consequences of security breaches, such as loss of sensitive information or damage to reputation, and the likelihood of such a breach occurring. Right? Based on this risk tolerance, organization can establish the level of security they need and determine which authentication factor they should use. Next is implement and test the solution. After selecting the right tools and technologies, what I have mentioned above over here, and determine the level of risk tolerance, organizations should implement their adaptive MFA solution and test it thoroughly to ensure that it works as intended and meet the security needs. This includes conducting regular security audits and updating the solution as needed to address any vulnerabilities. So this is what we have covered in implement and test the solution thoroughly. Next is provide user training. Organizations should provide training for their users on how to use the adaptive multi-factor authentication solution, including how to access the authentication factors and how to use the IAM software. So this is very much important. How to access the factor and how to use the IAM software. This will help ensuring that users are comfortable using the solution and understand the importance of using multiple forms of authentication. In summary, implementing adaptive multi-factor authentication in an organization involves several steps, including determining the types of authentication factor to use, selecting the right tools and technology to support, and establishing the level of risk the organization is willing to tolerate. Organization should also implement and test the solution thoroughly and provide user training to ensure a successful rollout. Let's find the real-world examples now. Here are few real-world examples of PSU banks in India that have successfully implemented adaptive multi-factor authentication. First one is State Bank of India. State Bank of India is the largest PSU bank, has successfully implemented adaptive multi-factor authentication for its online banking platform. The bank uses a combination of password-based authentication and the one-time passcode, which is OTP, sent to the customer's mobile device to confirm the identity of its customers and prevent unauthorized access to their accounts. Okay. Next is Bank of Baroda. One of the largest PSU bank again in India has implemented adaptive MFA to secure its online banking platform. The bank uses a combination of password-based authentication and biometric authentication to confirm the identity of its customer, right, to prevent the unauthorized access. Next is Punjab National Bank, also called PNB Bank, has implemented adaptive MFA and with a combination of password-based authentication and OTP sent to the customer's mobile device to confirm the identity of its customers and prevent unauthorized access to their accounts. Next one is Canara Bank, has also implemented adaptive MFA for its online banking platform, again with a combination of a password-based authentication and biometric combination. Let's summarize. Adaptive multi-factor authentication is a highly effective approach to authentication that can significantly increase the security of an organization system and resources. It works by using multiple factors to confirm a user's identity, including something the user knows, something the user has, and something the user is. The risk level associated with a particular login attempt is determined and used to adjust the authentication requirements, providing an additional layer of security. The benefits of adaptive multi-factor authentication includes increased security and a more convenient user experience. So this is very much important. The whole objective is it increases the security of an organization. It can help prevent unauthorized access to systems and resources by making it more difficult for attackers to gain access. To implement adaptive MFA, organizations need to consider the types of authentication factors they want to use, the tools and technologies they need to support, and the level of risk they are willing to tolerate. In summary, adaptive MFA is a critical component of a comprehensive security strategy and essential for ensuring the security of an organization's system and resources. That's it in this video. Thank you so much for watching, and don't forget to check my other videos for more information on cybersecurity and other topics. If you haven't subscribed to my channel yet, please do subscribe to my channel, like and share my videos. See you soon in the next video. Until then, goodbye, take care and keep learning. Microservice architecture has transformed the development landscape for both web and mobile applications, offering a paradigm shift in its stateless nature and loose coupling. This innovative design allows for creation of native mobile applications that leverage the same backend services during web application frontends. The concept of building once and utilizing multiple use cases has become a prevailing norm in enterprise design patterns. To address the scalability demands of numerous calling clients, notable strides have been taken in containerization and orchestration strategies, particularly on public cloud platform. However, these scalable design techniques have inadvertently increase the exposure of backend services to potential security threats, expanding the attack surface and associated risks. On top of it, the mix of heterogeneous technologies in microservices architecture, their distinct logging strategies makes the central logging difficult, which in turns loosen the security. Additionally, the complexity around building the resilience for fault tolerance across the decentralized networks adds to the security loopholes. These simple security designs, which were once used with traditional web application, cannot be used for microservice-based applications. Unlike traditional web applications, simple security designs are insufficient for microservice-based applications. This necessitates a re-evaluation of security strategies to address the unique intricacies and challenges introduced by the distributed nature of microservices. This video articulates the innovative approach to meet the security requirements inherent in safeguarding distributed services within the microservices architecture, offering insights into tailored solutions for the complex security landscapes of microservices-based applications. Traditionally, all the web applications were designed as monolithic in nature. In that traditional setup, MVC, which is Model, View and Controller, was the most popular paradigm. Applications would have a web server where all the static content like HTML, JavaScript and images was hosted. In an internet-based web application, these web servers are deployed in the DMZ network layer, and the web application code itself is compiled and packed as an enterprise archive file, ER file, or a web archive file, which we call WAR file, right? This archive file is deployed on the enterprise application servers like IBM WebSphere, BA WebLogic, JBoss EAP server, or Apache Tomcat server, widely used to name a few. These servers are deployed in the organization's internal network and shielded from being directly exposed to the internet. This archive file would communicate with the backend databases, other data stores, or would integrate with third-party services using web services or asynchronous integration mechanisms. As it can be understood from the diagram that the number of entry points to the backend layer are very limited in monolithic design structure. Not every layer or a component of the application is exposed to the outside world, and none of them would accept requests directly from outside. In a typical web application, all the input requests are scanned for security at the web server level, for example using LDAP system for user authentication. Once the request is authenticated, it then passes down to the application level. At this level, the requests are further filtered by a servlet filter. The security check verifies whether the incoming request is associated with a valid session identifier or not. If not, it challenges the incoming request session to authenticate first. Further, the authorization checks may be in place to validate that the requesting user has the necessary roles and permissions to access the intended resources. The intercepting servlet filter carries out such tasks centrally to make sure that only authenticated and authorized requests are dispatched to the corresponding resources. Internal layers and code blocks may not be concerned about the legitimacy of the request. They can be confident that if a request ends up there, all the security checks would have already been taken care of. On top of it, since these are stateful applications, the internal components can acquire the user information at any point of time by querying the web session in hand. It is the servlet filter which injects the incoming user information into the session variables during the initial filter process. However, the security design cannot be so simple in case of distributed microservice-based architecture. With the advent of cloud platform and discovery of containerization techniques using Docker and orchestrating software like Kubernetes or Docker Swarm have complicated the problem even further. Let's understand the design complexity in securing microservice architecture. Microservices architecture deals with breaking down the application to smaller and independent deployable units for getting a number of benefits as mentioned on the screen. To start with is a service isolation, separation of concerns, horizontal scalability and containerization, quick build cycles, easier maintenance, isolation of failures, and cloud portability, etc. This design has helped to solve many issues with the traditional monolithic applications, but at the same time it introduced the following security challenges. Since the logic layer and middle tier of the application is splitted into so many smaller and independent pieces, the attack surface has significantly increased. Also, due to the loose coupling of the front-end and back-end layers, it permitted multiple front-end systems to talk to back-end services, and this has also broadened the attack surface. With the rise of Internet of Things, many automated devices started interacting with the microservices layers, since there is no human interactions involved in this data transfer. Authentication and authorization are not straightforward. Due to these reasons, legacy techniques which were once used for protecting the monolithic web applications can no longer be used in case of microservice architecture. Since the backend microservice can be widely distributed, they can be present in a single data center or a cloud environment or a combination of data centers and public clouds. On top of it, unlike monolithic, the front-end and back-end are totally detached, and the back-end service can now be written in heterogeneous technologies. For example, few services might be running on Java language and other might be on Node.js or Python. The microservice architecture at a high level can be visualized from this diagram. Now let's understand how to secure the microservices. Traditionally, security teams have always focused on protecting the databases, network and infrastructure layers, but with the introduction of distributed microservice architecture, the attack vector has shifted to the server side of applications. This is evident from some of the major cyber attacks which occurred in recent times. A robust security design for microservice architecture needs to focus on these 5 main areas. First, securing the attack surface. As explained in the earlier section, the attack surface has snowballed in recent times due to the proliferation of the services using their containerization designs and auto-scaling features on public clouds. Front-end systems are isolated and can most likely to more than one, unlike the traditional design where back-end and front-end are packed as one unit. For securing the distributed microservices which are segregated from the front-end systems, there needs to be an authentication and authorization mechanism which can generate the tokens which are short-lived. The movement towards this approach caused software teams to look for security tokens that worked with RESTful and JSON format. Some of the token technology that involved from their requirement includes JSON Web Token and OAuth 2.0. Also, to reduce the exposure of services to the caller, there needs to be a single point of contact which can route the calls to the appropriate backend service. This gave a way to API gateways. This diagram describes the high-level design for using the token-based mechanism using API gateways. And here is a high-level flow which explains how the token mechanisms can protect the backend services. User requests the protected resource which is hosted on a microservice. Frontend checks if the valid token is present. If not, it sends the user to login page which has multiple authentication challenges depending on the organizational need. Once a user enters the authentication credentials, a call is made to the authorization server via the API gateway. Authorization server authenticates the user credentials by validating it with the identity provider. This can be any LDAP system present in the organization. If the credentials are valid, the authorization server returns a short-lived access token along with a refresh token to the front-end system. Front-end stores the refresh token. It calls the resource server again by passing the access token in the request header. API gateway has a filter mechanism which first validates the access token by firing an authorization check with the authorization server. If the check passes, the request is sent to the microservice for delivering the request needed by the user. If in case the access token is invalid, the authorization server denies access, which is handled by the front-end system as a message on the login screen. In case the access token is expired, the front-end system can request a new access token from the authorization server by passing the refresh token. If the refresh token is invalid too, then the front end can request the user to re-log into the application. This entire cycle gets repeated with every request by the users. Second is defense in-depth implementation. As we know the problem statement, backend services are of various sensitivities and priorities. It cannot be one size fits all strategy for all the services. Depending on the microservice, the level of security should be changed. For example, there may be public read APIs which can be exposed to all callers. There can be other services which can be exposed once the caller is authenticated, and there can be some other premium services or admin services which not only need to be authorized based on the user profile but also be protected carefully. Simple security token service with API gateway cannot be a solution for this need. For handling this kind of services, a strategy like defense in depth needs to be employed. Defense in depth is a concept in which multiple layers of security controls are placed throughout the system rather than a single defense system across all layers. For the use cases where an extra level of security needs to be implemented for premium or admin services, there can be an additional layer of security in the form of private API gateway which is not exposed to callers directly. This needs an additional filter and authorization scheme. If a caller needs to reach this inner secure layer, they need to access via facade services and pass an extra level of authorization as shown here in this diagram. Third is principle of least privilege. Due to the database per service pattern, each service is independent of the other, including the databases. For a transaction which joins multiple domains, services need to talk to each other either directly or via orchestrating Sega patterns. Many times inter-service communication is complex to implement. Such design would need to be intricately done. It is a challenge to narrow down the rules which govern the privileges and permissions for the APIs involved in the services. API needs to be designed based on the principle of least privilege. Access needs to be given only to those users who are not only authenticated but authorized to access the API. API access only needs to be granted based on the need. Start with the minimum access and only extend based on the need. Fourth is encryption everywhere. Services can be decomposed efficiently using various governing principles like common closure principles and single responsibility principle to achieve the maximum isolation, but the inter-service communication is unavoidable as the transaction span across multiple entities. Encrypting the data at rest using technologies like over-metric transparent encryption or by using the secure keys which are rotated once in every few days might solve this security needs for the data at rest. Also, the storage buckets for the files and caching mechanism should be encrypted using secure password. Not only the data at rest, but the data in transit should be encrypted using certificates and SSL layers. And the fifth area is continuous scanning, monitoring, logging, and implementing DevSecOps. There are various other problems deeply embedded in microservices architecture. Since all the services are stateless, independent, and heterogeneous, there cannot be a uniform logging pattern and framework. This makes threat identification difficult. The other challenge with most development teams is the early identification of the vulnerabilities before they creep to production. And also designing the security around the containers and various components is a complex challenge. So here is a solution. In case of microservices, it is imperative and essential to design a central log aggregation solution. This would also help narrow down the issue faster and avoid corruption to other layers and services. Along with these employs appropriate SAST, which stands for Static Application Security Testing, and DAST, which stands for Dynamic Application Security Testing scans, would mitigate the issues upfront. Also, the methodology of DevOps should shift to DevSecOps, where development, operation, and security team makes a combined call on microservices architecture rather than dealing with the siloed approach. Constant monitoring and feedback mechanism may be employed for better result. So we have seen some of the important concepts which are needed for securing the distributed service architecture. However, securing these services in a microservices architecture is a relatively continual process. A lot of research is also being done in the field of AI, where the threat can be forecasted based on the ODTs in the service requests, responses, or interaction pattern. These forecasts can be validated using the machine learning techniques to come up with mechanisms to avoid the infiltration. At the minimum, the service can be shut down by invoking the circuit breaker and alerting the responsible parties. Future scope of work including devising the innovative techniques to implement the multi-factor authentication based security which don't have any human interaction. That's all for this session. I will come up with more informative and interesting topics. If you have found this content informative and enjoyed this session, please like and share this video, and if you have not subscribed to the channel yet, please subscribe and enable the bell notification to stay updated on the latest content. Your support is highly appreciated. Thanks for watching. For every single human entity in your enterprise, for every employ every contractor, there are 25 to 50 machine identities running in the background. Service accounts, API keys, auth tokens, certificate, bot, AI agents, and here is the interesting part for security leaders, that 68% of IT security incidents nowadays involve machine identities, not human accounts. They are non-human accounts. If you look at the current identity landscape, most identity and access management programs were never built for this. And that is exactly why non-human identities have become the number one blind spot in enterprise security. Welcome back to TechFX and our brand new playlist, Identity Security Decoded. I am your host Amar Kumar, and in this series we are going to break down the hottest topic in IAM, customer IAM, PAM and IGA for security professionals, especially dealing in overseas markets. Today is episode 1 and we are going to explore what analysts from Gartner, CrowdStrike and CSO Online are all calling the defining identity security challenges of 2026, and it is about non-human identities. By the end of this video, you will understand exactly what NHIs are, why your existing IAM stack cannot manage them, a real case studies where NHI failures caused massive damage, and the emerging vendor landscape that is racing to solve this problem. If you work in identity, security architecture, DevSecOps, or you are a CISO trying to figure out where to invest your next budget, this video is right for you. Hit that subscribe button and the bell icon so you don't miss the rest of this series. Now, let's start with the basic. A non-human identity is any digital credential that allows a software system, an automated process, or an AI agent to authenticate and access resources without a human being directly involved in that specific transaction. Think of it this way: when you log into your company's Salesforce or AWS console, that is a human identity. You type your password, you complete MFA, and you are logged in. But behind the scenes, there are dozens, sometimes hundreds of machine-to-machine connections happening that never go through a login screen. Alright, sounds interesting? Let me walk you through the 6 main types of NHIs. First is service accounts. These are dedicated accounts that run automated processes like your backup jobs, your BOD processes, your database synchronizations, your monitoring agents, and so on. They often have broad permissions and continuously run. Second is API keys. These are static credentials that authenticate one application to another. Your payment gateway talks to your order management system using an API key. Similarly, your CI/CD pipeline talks to your cloud provider using an API key. Third is auth tokens. You must have heard. When you connect Slack to Google Drive or Salesforce to HubSpot, those integrations operate using auth token that persists long after you click allow. Fourth is certificate and secrets. TLS certificates for machine-to-machine encryption, SSH key for server access, database connection, strings, all stored in configuration files. Fifth is bot and RP identities. Your automation platform like UiPath, Automation Anywhere, and other RP platforms all create robotic identity that access production system. And sixth is the big one for 2026, which is AI agent identities. Every time your organization deploy a copilot, a coding assistant, a customer support agent, or an autonomous data pipeline, that agent needs credentials to authenticate. A single AI workflow can create dozens of new NHIs. Now, here is the problem. NHI outnumber human identities by ratio of 20:1 or 50:1, and in some hyper-automation environments, even over 100:1. And with the explosion of agentic AI in 2026, this growth is accelerating faster than any governance process can keep up with. So why can't your existing IAM stack handle this? Okay, let me give you 5 fundamental reasons. One is no MFA. Human identities are protected by multi-factor authentication. NHIs bypass MFA entirely. A service account authenticates with a static key. An API token does not get a push notification on a phone. Reason 2 is no lifecycle management for NHI. I'm talking from the joiner mover lever process aspect for human identities. When an employee joins a company, HR creates their identity. When they leave, HR triggers deprovisioning, right? NHI have no HR processes. A developer creates a service account one day and that account is still running with full privilege 3 years later also. Reason 3 is no behavioral baseline pattern. Your IAM system knows what normal looks like for a human users, like they work specific hours, access systems from consistent locations. So for human users, there are predictable hours, locations, and access patterns, right? In case of NHI, they operate 24/7 from anywhere. There is no normal to baseline against. Reason 4 is no ownership defined. Human identities have a manager who responds to access review emails. According to the report, 97% of NHI have excessive privileges and 92% of organizations are exposing NHI to third parties. Who is responsible then? Usually nobody. Reason 5 is no rotation discipline maintained. Research shows 71% of non-human identities are not rotated within recommended time frames. Okay, now the bottom line is most of the existing IAM platform, and some are calling themselves as a convergence IAM, their identity governance, access certification campaigns, and even IGA workflow, all of them were designed for human users. Whereas the NHI problem is fundamentally different and it requires fundamentally a different solution. Alright, now let's look at what happens when NHI security fails. And I'm not talking about theoretical risks. These are real breaches from past 18 months. The first case was Microsoft AI storage breach, where a misconfigured SAS token, that is a shared access signature, which is a type of NHI credential, exposed 30 terabytes of sensitive internal Microsoft data that included password, private keys, and internal messages. This was not a sophisticated zero-day exploit. It was a single overprivileged unmonitored token. The second case was Circle CI breach, where attackers compromised an OAuth token in Circle CI's environment. Thousands of customers were forced to rotate their secrets across their environments. And the blast radius was enormous because one NHI had access to the entire CI/CD pipeline. The third case was sales loft drift supply chain breach. This was called the biggest SaaS breach of 2025. Attackers compromised OAuth tokens that compromised 700 downstream customer environments. And the blast radius was 10 times greater than direct attack. The fourth case was Beyond Trust API key compromise. Attackers exploited a compromised API key to reset passwords for local application accounts in Beyond Trust support SaaS. The company had to revoke the key, suspend impacted instances to contain the damage. The fifth case is Red Hat GitLab breach. In October 2025, attackers compromised Red Hat's GitLab consulting instance and accessed nearly 28,000 private repositories and 800 customer reports containing network diagrams, database URIs, and live credentials. The sixth case was LastPass breach chain, where attackers exposed NHI chain and obtained access. They systematically created additional NHIs, enabling repeated intrusions over time. Okay, now here are the stats. The SpyCloud 2026 Identity Exposure Report found that 18.1 million API keys and tokens were exposed in 2025 alone, plus 6.2 million credentials tied to AI tools. Meanwhile, another research discovered that over 10,000 Docker Hub container images were leaking production API keys, cloud tokens, and CI/CD credentials into public repositories. This is not just a theoretical problem, this is happening right now at a massive scale. Alright, so the problem is clear. Now let us talk about who is building solutions. Right? I want to walk you through the four main categories of vendors and the key players in each. So here's the first category, that is NHI lifecycle and governance. These are the purpose-built platform that discover, inventory, classify, and govern non-human identities across your cloud, SaaS, and on-premise environments. In this category, Enter Security is in the first place. They build the NHI's lifecycle management layer with discovery, classification, secrets scanning, and behavior anomaly detection. News is that they recently raised $24 million backed by Dell Technologies Capital. Second solution is Oasis Security. They also raised $75 million from Sequoia, Axel, and Cybersecurity. They are building the agentic access management and governing not just what an identity is, but what is allowed to do at runtime. The third solution in this category is Asterisk Security. They focus on SaaS governance, auth control, and they recently launched an agent control plane for AI agent identities. Second category is secrets detection and scanning. GitGuardian is the dominant player here, expanding in NHI governance to cover the full life cycle. And third category is machine identity management. The big one here is CyberArk plus Venafi. For your information, CyberArk acquired Venafi for $1.5 billion, which is the single biggest bet on NHI security. Next solution in this category are SailPoint, Okta, and Microsoft Entra. All are adding NHI capabilities, though their primary focus remains human identity. And the fourth category is workload identity and access. In this category, Ambit comes first, and they are focused on replacing static credentials with short-lived identity-driven access. Next one is Achilles, and they offer SaaS native secrets management for enterprise, Vault as a service. It's quite interesting. Before we go further, let me put the disclaimer over here. All these solution providers are, as per my knowledge, and it may slightly differ from person to person research. Okay, a few things worth noting here. First, this market is consolidating fast, and large players will likely acquire these solutions. Second, no single vendor covers the full NHI lifecycle end to end. Now, let's talk about a 5-step playbook you can take back to your organizations this week. First step is discover an inventory. Run a full discovery across your cloud environment, SaaS integrations, CI/CD pipelines, and code repositories. Second is assign ownership. Every NHI needs a human owner, a person or a team accountable for its lifecycle, permissions, and rotations. Without ownership, governance is impossible. Third is Eliminate static credentials. Replace permanent API keys with short-lived tokens that expire automatically. Implement just-in-time access. Automate credential rotation on a defined schedule. For this right size privilege, 97% of NHI have excessive privileges. Apply least privilege to every service account, every token, every certificate. Audit permissions quarterly at minimum. And the fifth step is implement NHI detection and response. Deploy behavioral monitoring specifically designed for machine identities. Add NHI specific detection rules to your SIM and ITDR tools and set the alerts. Remember, this is not just a technology problem. It is a governance problem. The technology exists. What most organizations lack is the ownership model, the policy framework, and the operational discipline. Now, if you thought the NHI problem was big, wait until our next episode. We are going to deep dive into agentic AI identity. How autonomous AI agents are creating an entirely new class of identity that is even harder to govern than traditional NHI. Gartner named it one of their top 6 cybersecurity trends for 2026. That video is going to be essential viewing for everyone building or securing AI-powered enterprise workflows. If this video helped you understand the NHI landscape, hit that like button, and if you have not subscribed to my channel yet, kindly subscribe and turn on the bell notifications. Until next time, stay secure, stay curious, and I'll see you in the next one.
बार हुआ था ना। हाँ, तो दूसरी बार घर में रहोगी तो फिर होगा ही नहीं। कल कुछ हुआ था नहीं, करके निकालो ना करेगा। खाते हैं फिर 500 उसका साथ में दे देता है लॉन्ग पीरियड वैसे रह दूंगी मैंने तो बोल दिया अरे टिफिन तो दो अरे लोग तो पैकेट में खा लाते हैं कोई प्रॉब्लम नहीं है वो पैकेट में भी लेके गए थे मम्मा मैं टिफिन ले लिया Alexa, what is the time? अरे नहीं ले सकती चिप्स टिफिन ले नहीं सकते वो स्कूल बंद हो जाता है नहीं स्कूल बंद हो जाता है